Okay, can you see my screen?
Yes, we can see.
Yes, thank you very much. Yeah, so today I'm going to teach you in 2 new languages. Okay, now in this course we have a number of languages: SQL, relational algebra, and today I'm going to talk about relational calculus. We call all of these languages relational languages. So we have 3 different relational languages, but this one, which is the relational calculus, the one I'm talking about today, is divided into 2 sub-languages. One is called tuple relational calculus. The other one is called domain relational calculus. So I'm going to go through tuple now, and maybe after half an hour, I'll go through the domain relational calculus. So today I'm going to teach you a complete language, which is called the relational calculus. The good thing is what? If you know relational algebra, you already know relational calculus. Now let me give you just a hint about how relational calculus looks like. Relational calculus looks like this one. Always it has a bracket. 2 brackets, okay, and something like this. I think you have seen something like this, like x equal to f of x. Have you seen something like this in mathematics? Shabab? Have you seen something in mathematics like this?
Yes, we have.
You have, very good. Now let me tell you one thing. Now this x represents a variable, isn't it?
Of course.
Such that f of x. Now this x for us is a tuple or a record. So I have a table. So each record is represented by x. X is simply, it can be this, it can be this. It's a variable of type what? Of type record. So x is of type tuple or of type record, such that f of x. Now I'll explain what f of x. This is a condition. If this condition is true, this will go to the output, this x. If this condition is false, then this x will not go to the output. So this is a very, very simple language which contains just like this one. A bracket here, open bracket and close bracket, and such that put the variable which represents what? It can be x, it can be y, it can be t, doesn't matter what it is, to represent a record. Now, if this condition is true, then this record will be printed, it will go to the output. For example, let's take the first record. So x will be the first record. Then check this condition we're using the first record. If this first record is true, if the condition is true, then this will go to the output. Then do the same thing for the second row. Now x will go to the second row. Now check again the condition of x. So if this is going to give you true based on x, then this will be printed. Otherwise, it will not be printed, and so on. Yani. Is this point clear for you, Shabab?
Clear.
Let me give you an example. Assume I have a table. Assume I have a table like this. I have employee table. It contains, let's say, 4 rows. This is employee table. It contains 4 tuples, okay? Because we are talking about relational algebra, relational calculus, I should not say rows, I should say tuples, but that's fine. I hope you understand that. So let's make a condition now. What does this mean? X employee. Let me explain what I mean by this. X. What this means is the following. Give me X, give me any row, but what is that row? That row is in the employee table. So X is a row in the employee table. So this is a variable of type tuple. So it can be this tuple, it can be this tuple, it can be this tuple, it can be. But what is that tuple? That tuple is in the table called what? Employee. So X, which is in the bracket, is a variable, but where is that tuple? That tuple is in the employee table. So any tuple in the employee table will give you true. So automatically, what is the output of this condition is the 4 tuples, which are in the employee table. Are you with me? This is exactly like what? This simply means select star, I'm not going to put complete select statement, from which table? From the employee table. So this is just another, this is how we write it in SQL. This is how we write it in relational algebra. Is that clear, Shabab?
Dr. Kut,
Yeah. You are very far. I can't hear your voice.
Could you repeat?
Let me repeat again. Now, this is relational algebra, relational calculus, sorry. This is relational calculus. Always in relational calculus, this is how we write it. A bracket, another bracket. So open a bracket and close the bracket. Then put whatever variable you want to go to the output. This is the variable. Now, where is that variable? It's in the employee table. So simply means X is a variable. What kind of a variable? It's a tuple variable. The tuple matter, it can be this, it can be this, it can be this, it can be this, any of the rows. So it's a row variable. So it points to a row, or you can call it, this is a pointer of a row, okay? Now, but where is that row? That row is in the table called what? Employee. Okay? If I, instead of employee here, I write department, then it means X is a row in the department table. If I write here dependent, it means X is in the dependent table. So this shows me where X exactly is. But it can be any of the rows, yani. It represents any of the rows in the employee table. Am I making sense to you?
Yes.
Okay. So if I'm making sense to you, let me give you another, maybe much more things that will make even more sense to you, inshallah. Let me give you a different example. Assume I have an employee table. It has 8 rows. You remember our 8 rows in our employee table? Now I want to print the employee whose salary is above 5,000. So how do I write that one in SQL? In SQL, this is what I write. I write select star, select all the columns from what? From the employee table. I'm just going to write just to shorten it. Then I write where what? Where salary, isn't it? It's greater than how much? Greater than 5,000. That's how we write it in SQL. Do you agree with me, Shabab?
Yes.
Now, how do I write it in relational calculus? Very simple. Just write like this, and like this first, and like this. This is always there. So just to start with this. Give me X. Now, X represents a tuple, a record, the whole record. But where is X exactly? Is it in the department table or in the employee table? It is in the what? In the employee table. Put it in the bracket, the value X, so to show me this is in the employee table. But do I want every record, or do I want the records in which the salary is greater than 5,000? Then what you have to write is simply write and X dot salary must be greater than what? Than 5,000. So this is how we write the same thing in what? This is in relational calculus, but which relational calculus? Tuple. Tuple relational calculus. This is in SQL. Any question? What about if I don't want to print the whole row? I don't want the whole row. So this will give me, I don't know how many rows. Let me see the table. Let me see the table. Let's go to the table and have a look at the table. So this is the employee table. Assume this is the employee table. So which rows will be printed? These are all of them will be printed because all of them are above 5,000. But what about if it's above, let's say, 30,000? So let me see, change it a little bit. Let me put this one instead of 5,000. Let me put 30,000. Salary greater than 30,000. What do I get, Shabab? Let me show you the tables again. So which rows do you think this will give me? Will the first row be printed above 30,000? No. What about the second one? Yes.
Yes.
So the Franklin row will be printed. The third row will not be printed. This will be printed. This will be printed. This will not be printed. This will not be printed, and this will be printed. Is that clear, Shabab?
Yes.
So X represents a row. First of all, X will represent the whole row. Now, is the salary of the first row, to represent the first row, sorry, is the salary of the first row above 30,000? No. So the first row will not be printed. Now then X will go to the second row. So X represents the second row. Then is this salary greater than 30,000? Yes. So the second row will be printed, and so on until the last row. So that's what tuple relational calculus is. Simply a tuple relational calculus. This represents a row, and then this represents a condition. If the condition is true, print the row of the employee table. So go row by row and just check the condition. If any of the rows gives you the condition to be true, then print it. Otherwise, don't print it. Is this clear, Shabab? Let me ask you another question, a very simple question. What about if I want to print salary greater than 30,000 and let me put another condition, and sex is male? What do we write? What shall I add here?
I think you should add and statement.
Very good, and statement. And just like SQL, okay, whatever you write in the where group, put it here. So this will come from the from, and the rest will come from the where. Exactly like SQL, okay? In SQL, what do? We write and, isn't it?
Right.
And what? And sex equals to male, isn't it? So the same thing, just write sex equals to male. So in fact, it has a lot to do with SQL. So TRC is just like SQL, but in a very short way to write it. Okay. What about if I do this? What do you think I will get? I will get just like SQL, but without what? Without the where what? Without the where condition. Okay. Is this clear?
Okay.
What about if I want to print only the first name or the SSN? So what do I write here? So I have to remove this, and write what, Shabab? In SQL, what do we write? We just write what? SSN. So select SSN from employee. So it will give me only the first row SSN if the condition of that row is true. The second SSN and so on. And in this case, because I have no condition, so I will have 8 SSNs. But what do I write here? X dot what?
SSN.
SSN, because X represents the whole row, Shabab. So if you are looking for a particular column, you have to write X dot SSN, okay?
Okay.
Okay, so let me show you some examples. I hope that will make it clearer for you. Retrieve all employees. How do we write it in relational calculus? That's how we write it. I'm just writing it in a different way, but you can put them in 3 lines, or you can put them in 1 line. Give me E such that E is in the employee table, okay? Give me E, now E represents what? A whole row. Give me any E such that E must be in the employee table. So you read it this way, okay? This is print E such that E is in the employee table, okay? So معناته ايش? Every E in the employee table, معناته every row in the employee table will be printed. So this will retrieve all employees. At this point, clear, Shabab? You have done it in mathematics also. What about this? Retrieve the names of all employees. So I want the names now. So how do we write it? Just like this one. E dot first name and E dot last name, such that E is in the employee table. So it will go in the employee table, row by row, and it will print for you the first name of the first row and the first name of the last name of the first row. Then it will go to the second row and the same thing. Third row, the same thing, and so on. So to print all the 8 first names and 8 last names. Any question here, Shabab? Another example. Retrieve employees with salary greater than 5,000. So in this case, I already wrote it for you. You just write like this one. Is that clear? Is that easy language, Shabab? Okay.
Easy.
It's easy language. I think you have done it in maths. Actually, that looks like the one you did in maths, isn't it?
Yeah, and it's not like SQL, kind of.
Exactly. Exactly. I agree with you. Very good. Yeah. All you have to do is just put a bracket and another bracket, and this one, خلاص, you are half the way now, isn't it? Put the variable here, what you want to print. If you want the name, put x dot name. If you want the salary, x dot salary, and put the table in which the x, where x is. And then if you have any condition, put the condition. Just put and between the conditions, and so on. Okay. Retrieve the names and salary of all employees who work in department number 1 and whose salary is greater than 50,000. So that's how we write it. Select E dot first name, E dot last name from employee E, where E dot DNO equals to 1 and E dot salary greater than 50,000. It doesn't look like SQL تقريبا يعني صحيح. But what we do is instead of what? Instead of select, we write this. So this means select E dot first name, E dot last name. This is like from, isn't it? But we don't have where, we just say and على طول, and this, and so on. يعني. So this will answer this question for you.
Doctor, why they don't make like SQL originally? They don't make SQL except like this calculus, relational calculus syntax.
Yeah, the reason is if you are going to go for PhD and for what they call for masters, when you do research, this is just shorthand, okay? That's all, yani.
Shorthand.
Yeah, for SQL, okay? And it's just faster way to write SQL. Yani. Instead of writing select and so on, you can use this symbols, and that's the idea, yani, okay? But to tell you frankly, I did my PhD in what we call in databases. Yani. I never used the relational calculus. I used relational algebra a lot, but not relational calculus. Yani. But it's a possibility. You might use it depending on what problems you are solving when you are doing your PhD or masters. Okay. Yeah. Okay. Let's go to the next statement. What about if I have quantifiers? For example, don't worry about this part. Just understand this part. Quantifier. You have taken this one in any of the courses? Quantifiers in ICS 253, I think, is it?
Yes.
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 So, can we include quantifiers also inside relational calculus? Yes, you can do that. Let me show you. So we have two quantifiers. This means there exists, and this means for all, isn't it? So this is a universal quantifier, and this is existential quantifier. Yani. So this will be true if one of the rows is what? Is true. Otherwise, it is false. Universal quantifier, everything must be true. And you know this one from ICS 253, it's exactly the same, no difference. Yani. For example, let me take you here. This one, retrieve the names and the address of all employees who work for the research department. Now, if you look, where is the research department written? The research department is written here in this table, isn't it? So he wants every employee which is in here, but he must work what? He must work in the research department, صحيح? معناتها department number 5. Are you with me يا شباب ولا؟ But I don't have research here. I have 5 here, but I don't have research here. So I have to use these two tables. How do I use them? I will show you. So the question is, retrieve the names and addresses of all employees. So he wants the names, let's just take this name and this name maybe, and the addresses. This is what he says, right? So he wants John Smith and his address, Franklin Wong and his address, and so on. And that's what he wants. Okay. Retrieve the names and address of all employees who work for the research department. So how would you write it in SQL? You know how to do that in SQL, isn't it? But how do we write it in relational algebra? Okay. First of all, do you want to write it in SQL? How would you write it?
Select.
First name, isn't it? Comma, last name, comma, address, معي ولا إيه? From which table? From the employee table, isn't it? Where
ID.
DNO
DNOS
is equals to, okay, then I write another what? Another select department number from where?
Department.
Department table, isn't it? Where what? Department name is what? He's looking for what?
Research.
Research. And so research اكتبها كامل. Will this do the job يا شباب? Yes, it will. Zai?
Yes.
In SQL, you know SQL already, isn't it? So this will give me the SQL. But let me show you the what. But do you have a question with the SQL, how I wrote it, Shabab? Is that clear for you?
Yes, it's clear.
Okay, very good. I think that's easy for you by now, inshallah. But let me show you how you write it in what? In relational algebra. This is how we write it. This is what we do. Give me T dot first name, T dot last name, T dot address from employee T. So a T is a row in the employee table. So we will go each row of the employee table one by one, all 8 of them one by one. Then what do we do? For each one, we check if there exists a D. What's a D? D is another row. But this row is in where, Shabab? In the department table. So what he is saying is, go to the department table, give me a D, so that D dot name is research and D dot number equals to T, okay? Dot what? Dot DNO. So this is like exists, Shabab. We took exists, this is just simple like exists. So there exists D, okay? So this is what he did, like select T dot first name, T dot last name, T dot address from employee T, my wale, and exists, okay, department in the department table D such that D dot D name is research and D dot number is what? Equals to T dot D number. So let's go to the first one, for example. Let's go to the first one. Let's take T to be this one. So this is our T now. This is our T. So this would represent our T. And let's take what? T dot DNO is 5 now. So now let's go to what? Let's go to, first of all, what is the T dot first name? Are we going to print it? But let's check first of all the condition. Now, so there exists a D such that D dot name is research. So fine. And D dot number equals T dot numbers. Now, do I have a row in the department table in which the D dot name is research and D dot number is 5? Let's check. Do I have a row here in which D dot number is 5 and D dot name is research? Do I have a row here? ولا لا شباب? Yes, the first row.
Yes. Yeah.
So yes, we have. So in that case, so this will return what for me? A true for me. So if this is true, the first row, T dot first name, T dot last name, T dot address will be printed. معناتها this will be printed. John and Smith and the address of John Smith will be printed. After we print that, then we go to the second row now. The second row also is 5, say. So we go here, we check if there is any row, department name is research and department number 5. Do we have that row? Yes, department name research and department number 5. Yes, we have. So the second row also first name and last name and research and the address will be printed. Then go to the third row. Now this time is what, Shabab? DNO is what? 4. Now in this table, do I have DNO 4 and D name research? Do I have a row in which the D name is research and the department number 4? Do we have that?
No.
No. Very good. So what will happen is this will return what? False for me, because I don't have, for the third row, this is 4, Shabab. So I don't have a row in the department table, in the department name equals to research, but the department number 4. I don't have such a row. Okay? So this will return false for me. So the third row will not be printed. So this row will not be what? Will not be printed. So this will not be printed. What about this? This will be printed or la?
No.
Jennifer, no. This will be printed and this will be printed. So 4 rows will be printed, but the other 4 rows will not be printed. Any question here, Rashid? Any
Yes,
question?
can you go back to the
relational algebra?
yes?
Yes.
There exists it returns a Boolean, right?
So there exists a D, exactly, always this one is true or false. So this means n true or n false. So you'll get a true or a false out of this.
So when it is true, I return
exactly.
t dot if name dot t dot.
Exactly. So take the first row from the employee table, then check if the DNO of the first row is equal to the DNO of the second or from the department table, but the name must be research. Okay?
It's different from inner select because inner
No,
select.
yeah, I agree, but it is like this one, select.
Yes, it is the same output, but
No, it is existence. Do we have, you remember existence, عندنا? It's like existence. Let me show you existence. Select.
but you did it without exists. Right?
Yeah, I did it without existence, but this is exactly existence. In fact, this is existence exactly. In fact, this is more than the one I did does not exist. In fact, the one I did is not exactly like this one, but existence is the one exactly like this one. Let me show you.
Okay.
Select what? First name, last name, and address. معي ولا إيه?
Yes.
From the employee table, isn't it? T. Okay, so this is the alias. Okay, where, okay, existence.
Okay.
Where existence, then open bracket, select, doesn't matter anything. Okay, one, isn't it? From the department table D, where D.D number is research and D.D number equals 3 and all. So it's exactly like this one. So this existence will give you what? If any row exists, matter this is true. If there is no row existence, then this is what? This is false. So it's exactly like what? It's exactly like existence, yani. But I avoided existence. I felt like you stole. Some of you didn't still understand existence. عشان كده يعني.
Yes. And for universal, you put exists all or something.
Yeah. Let's have a universal quantifier example. Any question here before I go to the universal one, Shabab? Find the names of employees who have no dependents. Okay, this is just another example. This is how you write it, yani. Okay, not exist. معي ولا إيه? Shall I solve it or it's clear for you? Anybody who wants me to do this?
Yes, please do it.
Do it, very good. So I'm looking, let's take the first row. First of all, this is the employee table. Let's look at the first row. Now this is the first row, and we take what? We take his what? His SSN. I'm looking for his SSN. So I'm looking at the department table for SSN, which is like the SSN of the first row from the employee table. So let's take the SSN of the first row. So what's the SSN of the first row? It is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, isn't it? So always start from the first row. Let's start from the first row. Is this going to be printed or not? So let's take the SSN of the first row. Why SSN? Because he's using SSN to check. So what did he do here? He said, okay, print the employee.first name, employee.last name from the employee table, but he should not exist what? He should not exist here in the department table. So I should not find the SSN, which is equals to what? ESSN. So I will go to every ESSN is the department table, and I will compare it with my SSN. If any one of them is true, this condition is what? Is true. Not true means what? Not true means what, Shabab? Not true means false. معي ولا إيه? So yes. False معناتها this will not be what? This will not be printed. So let's take the first row, and then I will explain for you what do I mean. So let's start from the first row. In the first row, let's take the first row from the employee table, and let's take it SSN, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So خلاص, now we are taking what? So ESSN, which is this one here, is going to be what? 1, 2, 3, 4, 5, up to 8, I think. صحيح? Now, do I have in the department table in which ESSN is the department table equals to 1, 2, 3, 4, 5, just like the SSN? Do I have? Let's check the department table. Dependent table, sorry. Dependent. I have 3, 3, 4, 4, 4, 5, 5. I have 3, 3. I have 1, 2. Oh, I have here. Say, I have here. I have here. I have here. So معناتها this person who's Mr. John, he has dependents. How many of them? 3 of them, isn't it? So because he is in this table, معناتها he has dependents. If he is not in this table, معناتها he has no dependents. Because he is in this table, he has dependents. So if he exists in this table, so this condition will be what? This condition will be true because I have a row in this table called dependent in which Mr. SSN is available. So this is true. Not true will give me what, ya shabab?
False.
False. So because this is false, he will not be printed. Because I'm looking for those who have no what?
Dependent.
No dependents, isn't it? So the first guy will not be printed because he has dependents. So let's go to the second guy, who is what? Mr. Franklin. His ID is 3344555. So take this guy and check whether he is in this table. 3344555. Oh, he's also here, say? So because he is already here, so he exists in this table. So we are looking for those who doesn't exist. Exists, this will give me what? This will give me true again, because he exists. So not true means what? Means false, so he will not be printed because now the condition becomes false. Now let's go to the third guy. So this will not be printed. This will not be printed. What about the third guy, Miss Alicia? Alicia, her ID is 9998877. So do I have 9998887? No, I don't.
Right.
No. So when I go to this table, I will not find the SSN which is equal to ESSN like Alicia. No one is like Alicia. So this will give me what, Shabab? Will give me false. It doesn't exist, isn't it? So this is false. So not false will give me what? True, isn't it? So yeah. The condition is true. So Alicia will be printed. So I will look at her. I will have her first name and her last name will be printed, and so on and so on. Is this clear, Shabab? Is this clear?
Yes, it's clear.
Yes. Okay, very good. Okay. Simply you can write it in SQL and then you can convert it to relational algebra. Very simple. Okay, very, very simple. So this is just like SQL. بدل هذه اكتب select. Then E dot first name, E dot last name. بدل هذه, what do we write? From, isn't it?
Yes.
From, no, we don't have the bracket here. We just write E in SQL. We don't write brackets. Then we, instead of this, we write what? Where. The first and has to be converted into where. Where not, we don't need this one. خلاص. Exists. بدل هذه activation exists. And then write select one from dependent and so on. So you can convert any relational algebra or relational calculus into SQL. And you can convert most of the SQL very easily into relational calculus, into one relational calculus statement. Okay, I hope you got it. Okay, so I want you to try this and see whether you understood me or not, and then I will solve it after that. So please try this. List the names of managers who have at least one dependent. So I want this time, I want the managers who have dependent, not everyone. He has to be a manager. So what do we do, Shabab? Let me tell you, show you the table. I have 3 managers. This is a manager, this is a manager, and this is a manager. So these are the 3 managers. Now, anyone who has a dependent out of these 3 will be printed. List the names of managers who have at least one dependent. If you are in this table, خلاص, you have a dependent. So how would you write it, Shabab? Do it in SQL first. This is a typical question, and then you can convert it into relational what? Tuple relational calculus very easily.
Select name from manager.
So how do we write it in SQL? Select
name.
First name, isn't it?
Yeah.
And what?
Name.
And last name, is it? Name of the manager, صحيح?
Yeah.
From where?
Manager.
The employee table, صحيح?
employee or
Employee table, isn't it?
Yes. Where?
Okay, where
Yeah.
SSN
Is equal.
in,
Oh,
no, don't
and-
put equal,
and- yes,
put in, because it can be more than once, right?
Yes.
In select what? MGR SSN, صحيح?
Yes.
From the department table, isn't it?
Yeah.
And okay,
And
SSN also must be what?
in the dependent table.
Exactly. He also must be in what? Select, صحيح? Isn't it?
Yeah. It's
ESSN, isn't it? ESSN from the dependent tables and so on. So this is how we write an SQL, صحيح?
right.
But how do we do that one in relational algebra? You have to use existential quantifier in الحين. Okay, so I want you to write it, and I will give you 5 minutes. After that one, I will show you my solution. Please do it on your own, okay, Shabab? Try. I'm sure you will make a mistake, but you will learn from it, okay? So I will give you 5 minutes. Do it, and then I will solve it for you. So I want managers who have dependents. That's all I want. So let me show you this to help you with your SQL. So I want out of these three, I want their first name, last name, and the first name, last name is here, but he must exist here. If he exists here, he has dependent. So find out any manager who is here, and then print his first name and his last name. When I show you mine, it looks easy. Try it yourself and see whether you have understood. You will learn a lot by your mistakes, okay? Not by my corrections. First of all, do this so that you can get at least some of the grade, okay? There are many ways to do it. You can do it by join, okay? You can, for example, I can join this table and this table, and so on. You can do it also by the way I showed you. There are many ways to do it. There is no one way to do it. You can join all the three tables also. Okay, so let me show you the solution now. It's 5 minutes تقريبا. Do you need more time ولا?
I think it's enough.
That's fine. Okay, so let me show you the solution. This is my solution, but you can have a different solution. For example, this is how I did it. So I used some kind of a join here. يعني. You can do it in a different way. Give me the first name and last name from the employee table, okay? And there exists a row called D and another row called P. So this will be in one table, this will be in another table. Where is D? D is the department table, P is the dependent table, such that this is like a join. يعني. E.SSN must be equal to D.manager SSN and P.SSN must be E.SSN. Okay, Shabab, so this also will give you the solution.
Doctor, I have a question.
Sorry, yes.
Go on, Omar. My question is, why you didn't use 2 ands in the beginning and used 1, and how?
Okay, very good. So always in relational, very good question, excellent. In relational algebra, in relational calculus, what we do is when the first table, always we put it like this one. So, but the inner tables, we can put them like, okay, there exists and there exists. Okay? Is that your question, Willa?
Yes, but.
So, but this is one way to do it. There is another way to do it. Also, you can also do this one in 2 different steps. Also, that's fine. Okay?
Okay. Now I
can say
both ways.
And there exists D, and then you can say and there exists also P. You can also do that, no problem.
Okay. Yeah, I did that, Doctor. Is that correct?
Oh yeah, that's
so
also correct.
There exists and there's an open bracket.
Yes.
Department ESSN equal manager D.manager.
Yes, you can do that. That's fine.
And the order is not important of the and. The order of the and is not important, of course.
Yeah, it's not important. Yes, it's not important. So there are different ways to do it. As I told you, this is just one way. Yani. I just want to show you a different way. That's all. Practice this one, okay? Maybe the first time it's a little bit weird, but after some time it is very easy. Yani, okay, very easy. Okay. I'm thinking to give you one of the quizzes on this one, okay? And then I will just forget about it. Yani. I don't think I will include this one in the final. Yani. Too many languages. خلاص كفاية. So one quiz on this and that's it. And if Mr. Jawid agrees, I have to talk to Mr. Jawid. Okay, let's go now to the next one. So this is, I don't want to start this one because this is a different language. Let me do it. Domain relational calculus. It's just like type relational calculus. The only thing is what? The only thing is this one represents a column now. It doesn't represent a row. So this U represents a column. V represents another column. Which column? Let's take the employee table. How many columns do I have in the employee table, Shabab? How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Are you with me, Shabab? So what you have to do is this is another language, Shabab, not the same language. Let me take you back to this story. Remember I told you we have 2 languages. We already know this language. We already know SQL and we already know relational algebra. Okay. So today I was talking about relational calculus. And I showed you tuple relational calculus. In this case, the variable is a tuple. The variable is a tuple, a row. Yeah. Now I have another relational calculus, but the variable is a domain, a column. So we call it a domain or a column. In this case, he means a column, okay? So you can call this one CRC instead of DRC, okay, if you want to. So in domain relational calculus, so we will have a variable, let's say x, such that f of x. So f is the name of the table, x is a column in f, okay, Shabab? And x represents a column now. Here, x represents a row. So x represents a row in here, but in here, x represents a column. But which column? Maybe in the employee table, I have 10 columns, right? So for each column, you have to write a variable like this. So this is an employee table. Let me put the employee table together with what? With the other table, which is this table here. So I don't know if I can say it like this. see them يا شباب clearly? Do you
Yes,
see both of them?
kinda. Yeah.
Very good. Yeah, it's not clear. It's not clear. So here I'm saying the following: give me U and V such that in the employee table I have columns Q, I have columns R, S, T, U. So U and V are here. What do they represent? Q represents here first name, because this is the first column. The second column is represented by R. The third column is represented by S, then by T, then by U, then V, W, X, and Y, Z. So I'm going to print U and V for me, معناتها column U and column V. But what are column U and V? Column U and V are the one in position 1, 2, 3, 4, position number 5, and position number 6. So what's position number 5? This is position number 1. This is position number 2. This is number 3. This is number 4. Number 5. So number 5 is what? Birthdays. Okay? So it will give you this column. And number 6 is address. So this is like giving me the birthday and what? Print the birthday and what? And the address. This is what it means. يعني. But this is how we represent يعني, domain relational calculus. So here, every variable represents a column, not a row. Isn't it weird, يا شباب ولا? Okay, it's a little bit strange.
It's weird. Why he doesn't start with A, B, C, D?
You can do that. It's up to you. You can do that. But just to show you that you can use whatever you like. You can put A, B, C, D. You can put Z, W, X, Y, Z. The order here must what? Each one will matter, but it doesn't matter which order you follow here. It's up to you. Okay. Just make sure that your table is less than 26 characters. Otherwise, how many characters in English? Is it 28 or 26? I don't know. Anyhow, so make sure you don't run out of characters. Sorry?
26. Can 26. I have like composite characters?
No, they don't.
Or maybe
each character represents one column. Huh?
Characters and numbers, maybe.
No, they don't have that. All I know is this one, yani. Okay, so it's good for small tables, yani. So this is another. Yes.
This will return the column and its content, the whole column.
Yeah, the right? U and the V. It depends. So in this case, for example, it will return this 8 and this. So it will return this. Okay.
I mean the tuple relational calculus
can
return. Yes, I mean the tuple can return birth date and address.
Yes.
You say
yes. So in that case, you have tried T dot birth date, T dot address. You have tried that one. Yes, it will do that because, or X dot birthday, or X dot address. Okay.
So why do you need the domain?
This is another language. Okay. Another language. So a separate language. You remember I told you the relational calculus is divided into 2?
Yes.
So one is tuple relational calculus. In this case, we just represent T represents X represents a tuple, a row. So if you want a column, you have to write X dot something.
Yes.
But here in DRC, X represents a column. It doesn't represent a row. Okay.
So we could generate any output using these two.
Exactly.
The same output.
Okay. Yes, you can do that. So simply here, for example, here, what I do, I say print U and V for me from the employee table, and this is how the columns are represented. Q is for first name, R is for, and so on and so on. Okay, so U is a column number 5, and V is column number 6. So you have to put all the 10 columns here. Gives each column a variable. Okay. So the first one is for the first one. The second one is for the first one. The order is the use A, use B. It doesn't matter. Okay, you can use whatever you want. The order is the most important here. Okay.
Yes.
Another question is this one. Retrieve the birthday and address of the employees whose name is Adil Muhammad Ali. So Adil is first name, M is the initial, and Ali is last name. So what do we do here? Print U and V for me. So I'm going to print the birthday and what and address. So U is the birthday, which is number 5, and V is the address. So print UV, where U is print. Okay, and Q is Adil. Q is first name. Say Q is first name, isn't it? So first name is Adil. R is the second one with middle initial is M, and S is the last name is equals to Ali. So make sure that you have what? You have this table near you. Otherwise, you will not you will not be able to answer. So this is Q, this is R, this is S, this is what? T, U, V, and so on. Okay. So another language. Okay, and so on. So this is a language, but this time I'm using what? Quantifiers. But what you put here is also columns. So and so on. So I will leave that to you, Shab. It's a very easy language, so you can do it yourself. And if you have any question, you can ask me during my office hours. Relational calculus. So I'm thinking to give you just one quiz on this, and we'll just forget about it. Okay?
Doctor, regarding the quiz.
Yes. Which quiz? Quiz next week, isn't it?
The upcoming quiz, yes, on Monday.
Yes.
November 16. Can we shift it just to?
I will just give me a minute, okay? So let me just stop recording.